So this would be the continuation of our lesson. And today we're going to look at isotopes. So you should have your worksheet because you're going to complete them. And after that, you're going to answer the questions on the worksheet. So I would like you to see and understand what are isotopes and what would be how you're going to differentiate this from ions later on. So the number of protons in a nucleus determine the identity of an element. Okay, again, the atomic number will determine the number of protons. So for example, the atomic number is 20. So that would be the proton of this element, which is calcium. And for example, the atomic number would be 79. That is how much proton this gold has. So the number of protons in a nucleus determines the identity of an element. So if you will look at here, if the protons is being added, you're going to be changing the element. Okay, the element is being changed, and if we add an extra neutron to a nucleus, right? We simply end up with the same element, just a little heavier since the charge on the nucleus would be unchanged. In the other words, isotopes have the same number of protons, but a different number of neutrons. The isotopes is identified by its mass number, the sum of the protons and neutrons. And the most common isotopes of carbon has a number of 12, and it can be written as C12. Two other isotopes are carbon C13 and C14. Okay, so despite their different mass number, all three carbon isotopes react the same way chemically. So what is being changed on this for it to become an isotope is the neutron. And each of the elements has zillions or billions and trillions of isotopes or variety of each of these elements. So what is an isotope? So you will put in there, isotopes are versions of the same element. They have the same protons and electrons, but different mass number and number of neutrons. All right, so that's an isotope. It is just like your ice cream. There's a lot of variety of ice cream, whether you like the mango flavor, a strawberry flavor. They're all ice cream, right? Even cars. There's a lot of versions of cars. There are hundreds of versions of cars. Maybe you can name a lot of them, but they're all cars. So the same thing with atoms. Atoms are just different version of the same element with the same protons, but it has different mass and neutrons. Okay? So how it looks like. This is how we're going to understand that. So for example, here is an example of an atom. And you will see here the proton for this first atom. 1, 2, 3, 4, 5. They got 5 protons. And also here, they have 5 protons. So if you will be looking at the table of element for number 5, atomic mass number, that is your boron. So boron has atomic number of 5. So that is the number of proton. And the neutrons, the thing is the neutrons here are different. So in this first atom, we got 6 here and we got 5 here. All right. So remember, isotopes has the same protons, but different neutrons as well as mass number. So how are we going to look for the mass number? We are going to add 5, and 6. So that would be your mass number. And also here, 5 plus 5, we got 10. So this is the same element, but they have different neutrons. So this is an isotope. So how are we going to weigh this? So since we talk about weighing uh, on the first topic, we says that one proton is equivalent of 1 AMU. So also neutrons. So you can see here that the mass number is 11. So you will say that it weighs as 11 AMU, and protons plus neutrons are 5, 5. So this weighs as 10 AMU, right? So we all know that this is an isotope. We call this one as, since the mass number is 11, we can call this one as boron 11, and we call this one as boron 10. The atomic mass is the average number of protons and neutrons. Okay, so now for boron, how are we going to look for the atomic mass of a boron? We already know that the atomic mass is 10.8, but how did it happen that they have 10.8? So the atomic mass is the average of protons and neutrons of an atom. So how are we going to look at that? So for example, let's take 50 boron randomly. So inside of this would be your boron 11. Let me just say boron 11. Inside of this would be your boron 11 and boron 10. So think about like this boron 11 is 80% and boron 10 would be your 20%. So based on this percentage, we will know that there are more boron 11 here. So how are we going to look at the average atomic mass of a boron? So you might be thinking that, oh, I will be adding boron 11 plus boron 10 and we're going to divide into 2, right? And that would be your 10.5. So you will see here that would be, this is how you get the average. But no, since we have 80% here and 20% here, we cannot choose this unless there will be 50% each of the boron 11 and boron 10. So how are we going to look for the atomic mass number? So looking for the atomic mass number, we're going to multiply 80% times 11, and we're going to add it into the 20% of boron 10. So you will see in here that if you're going to multiply this and add it with 20% of boron 10, you will get your 10.8 as your atomic mass. And this is how they get your atomic mass. So again, the atomic mass is the average mass number or the average number of proton and neutrons of all the isotopes of an atom. So you will see here that that's where they got the average that they put here on this atomic mass. Finish what?
The presenting. Also scary. The speech of the country. No, it's so scary. Because they asked me so many questions. Like about 30.
Is that social studies?
People is like about 5.
Bye. Right, so that is your atomic mass. Now how are you going to write an isotope and how are we going to use the number and the symbol of an isotopes? So look at this example. We got carbon 12, carbon 13, and carbon 14. So you will see here that the carbon 12 will say, or that means that the carbon 12 has a mass number of 12. The 13 has a mass number of 13, and has the carbon 14 has a mass number of 14. This is the number of the element, and it has 6 because that signifies that the protons are just the same, or the atomic number are just the same. Okay, so this is how you're going to make your isotopes and how you're going to put the symbols for isotopes, or what we call your nuclear notations. So now, what does the number of next two isotopes signify? So the number of indicates the isotopes mass number. Okay, so again, it will signify the mass number. How can you tell isotopes apart? So they will have a different mass number and different number of neutrons. Okay, so that's your isotopes. So what does your chromium 58 and chromium 63 mean? So you will know that 58 is your mass number. And how are you going to be looking on, how are you going to look for the protons, the neutrons, and electrons? So first, let's just take a look on protons. We all know that protons and electrons are the same, right? So the protons for chromium is, we need to go find the element. What is the atomic number of chromium? So if you will look at the table of element, that has 24. Okay, so the number of protons here is 24, as well as the number of electrons. So 24 for chromium, and since these are two elements which has the same protons, they are all 24. Now, how are you going to look at the neutrons? Remember, the mass number is your protons plus your neutrons. So since 58 is the total, we're going to deduct that from your protons. So 58 minus 24, you got 34 there. And that's your neutrons. For 63, we're going to deduct that also with 24, which is, if you're going to deduct that, we got 39. Okay, and that's how you're going to complete this table. Next one, we got carbon 12 and carbon 16. The number of protons again depends on the atomic number, which is you need to find and see your periodic table, how much or what is the atomic number of this element. So for carbon, it has 6 atomic number, which is it has 6 protons and it has 6 electrons. So since there are 2 carbons and they have the same protons, they are 6 and 6. Okay, so how are we going to look at the neutrons? So you will see here that we got a mass number of 12 and mass number of 16. So for us to find these neutrons, we're going to deduct 12 minus 6 for us to get 12. Because again, if you're going to add neutrons and protons, that would be your mass number. For this one, we're going to deduct also 16 minus 6, which is 10 would be their neutrons, because if you're going to add neutrons plus protons, we get the mass number of 16. So, all right, this is how you're going to answer and find the number of protons, neutrons, and electrons of these isotopes.